This next video is going to require the use of a calculator. The next equations that we're going to come across will require you to give an exact answer and then to give a decimal approximation. So we saw before that when we have an exponential equation, when the bases are the same, that meant that the powers would then be equal. So you go from here to here. Now we want to look at something that's similar to this, but just a little bit different. If you have an equation like this, you can apply a logarithm. I don't care what the base is, as long as it's the same. You can apply a logarithm to both sides of the equation, and it's still going to be something that's true. So you can go to here, you can go back up here, just one big circle, one big happy family. And you might be wondering, why do I need to do that? Why in the world would somebody take a log of both sides? Well, because some of those exponential equations that we're going to come across don't work out very nicely for us. If I say solve 2 to the x equals 3, in the past, I would have said, find a common base. Well, what's the common base between 2 and 3?
None.
There's not a common base. There's not a nice way to go from 2 to 3 or vice versa, and you can't break these guys down anymore. So instead what we do is that we apply a log to both sides. I don't care what you use, as long as it's the same one. So we tend to use, because we have the calculators in front of us, we tend to use natural log or the common log. So I can do this. I can apply the natural log to both the left side and to the right side, like this. By doing so, you now have 2 to the x inside a logarithm, so what can you do to its power? You can now bring the power out to the front. So this becomes x times the natural log of 2 is equal to the natural log of 3. Right, these are known values, right? Natural log of 2 is a constant. It may not look pretty, and you might see that there are some letters in that expression, but this is just a number. This is just a number. So how do you get x by itself? You divide by that number that doesn't belong, which is the natural log of 2. That natural log of 2 is a single entity. It's not made up of natural log and 2. It's the natural log of 2. So it's a single value. It's a single expression. And so this means that I have x is equal to the natural log of 3 over the natural log of 2. Notice I'm using equal signs here. This is an exact value. This has all of the information, all of the decimal information for the answer here. But what we're going to do is that we're going to now rewrite this as a decimal approximation. Now for me, I just like to have all of my stuff rounded to the nearest thousandth, which means to 3 decimal places. So I'm going to go to my calculator, and be very careful about what I type in here. So I'm going to do natural log of 3. As we talked about it before, you have to close off your parentheses, then divided by the natural log of 2. Most of the mistakes that students will make when it comes to these problems is they don't close off the parentheses correctly. So I'd hit enter, and I come up with 1.585. And you might say, okay, but you used natural log. I used common log, so shouldn't I get something different? Let's see. If I do log of 3 divided by log of 2, as long as I'm closing off my parentheses correctly, we get the same answer. There you go. That's it. What do you think? You You want to see this on your test, don't you? Cool. Your wish is my command. Now, over here you could have used common log or natural log because it didn't really matter. But in this next example, it really does matter in terms of the ease of doing the problem. If I do e to the x plus 1 equals 5, again, you have your variable up in the power, and the way we get it out of the power is by taking log of both sides so that the power can then come out in front by those properties of logarithms. Since my base here is e, it would make sense for me to use what kind of logarithm? The natural log. So, the natural log of e to the x plus 1 equals the natural log of 5. Now, I know some of you guys are motioning that we're going to bring the x plus 1 out front. Yes and no. What is understood to be the base for a natural log? E. So the base of natural log is e. Inside it is e. So when you simplify the whole thing, what?
1.
Well, it kind of reduces away, becomes 1, and so all you're left with is the power. That's why I wanted to choose the natural log here. And so all of this just gives me x plus 1. And now you just have to solve this for x, right? I mean, how hard can it be? Is it hard? No. But here's what I'm going to say to you. When you subtract 1 and you move it to the other side, to avoid confusion, this is why you have to learn how to write things well mathematically. Bless you. Write this in front and say negative 1 plus the natural log of 5. These were already two separate terms, so don't even try to put them together. By putting the negative 1 in front, we understand that it's not connected to the 5 at all. If you do it behind, sometimes there could be confusion, and so we want to avoid that by writing it this way.
But most of the 5 is in parentheses.
Right, but if I do it like this, there's never going to be a question about what's what. Okay, and then we go to our trusted calculator, the one that you sleep with at night, provide you comfort and peace when you have those nightmares about English papers. So let's type this in, right? So negative 1 plus natural log of 5, right? Oh, wait a minute, what's going on here? Why is it doing that? Why is it doing that? Oh, I pushed the wrong button. Oh, because see, here's the thing, in case you guys did not know, for playing along at home, if you press the minus button, any of these 4 buttons here requires something both before and after that symbol. If you're leading off with a negative for your expression, you use the negative button down here. My calculator gave me the wrong answer. No, it just gave you exactly what you told it. So negative 1 plus the natural log of 5. So 0.609. That's your approximation. So what I'm looking for on a test is I want to see your exact value right here, and I'm going to ask you for your approximation. Too easy, right?
I hesitate to say yes.
Oh, I don't ever make things difficult. Remember, it's not me, it's you. Let's do 5 to the x minus 2 equals 3. Do these guys have a common base? No, they do not have a common base. So we kind of force them to have a common base by applying logs on both sides. So what log do you want to use? ln.
It's nicer to write.
Okay, maybe it's nicer to write. Doesn't matter though. So if you want to do ln and somebody else wants to do log, does it matter? No. Your answers might look a little bit different at the end, so instead of having natural log over natural log, you'd have log over log. It's still going to be the same thing. So I tend to do natural log. I don't even know why. So the natural log of 5 to the x minus 2 equals the natural log of 3. The purpose behind taking the log of both sides is so that I can do what now?
You can now bring x minus 2 as a term to the front.
Bring the x minus 2 as a factor out in front of the natural log of 5. Be careful when you do that, though. Here's what bad students do. I shouldn't say bad students, but unaware students would write this. Whoops, why did I write like that? So I guess this is my editing phase of the video, right?
Editor's not working.
There we go. Why did I put there's a power? That's dumb, right? There we go. Is that better? Maybe I will edit that one out. So what's wrong with what I have here in this expression?
There's no parentheses around the x minus 2, so you're going to get misguided about what you're
There are no parentheses around the x minus 2. This whole guy was supposed to come out in front. This whole thing. Which means it's a factor and it's connected like that. Without that set of parentheses, you get something that's totally different and very wrong. All right. Natural log of 5 is just a what?
term, it's a number.
It's just a number. It is a constant. If you type in natural log of 5 in your calculator today or tomorrow or in 100 years, you should still get the same decimal value. Which means we can distribute that to this. So we can say that this is x times the natural log of 5 minus 2 times the natural log of 5. That's distributing. This is your x. This is the only instance of x, so start peeling away the layers until only x remains. What's the first thing you have to peel away?
Divide by ln.
I don't think that I would do that right now. Here, I don't want to do any division until I've moved this other guy to the other side.
Right.
So I would add 2 natural log of 5 to the other side. So now I have x times natural log of 5 equals the natural log of 3 plus 2 natural log of 5. And then how do I finish getting x by itself?
Then you do.
Now I can divide by his coefficient, the natural log of 5. And I end up with x is equal to this big fraction over here.
Except it doesn't have to be bigger.
What do you mean?
Because you have ln.
You just want to cross these guys out?
No, it's. Yeah, I guess you can.
No, you can't.
Yeah.
Because natural log of 5 is not a common factor for everything up here. This is going to be exact, and we can go ahead and do our decimal approximation. Now here's where you have to be very, very careful. When I do my decimal approximation, you have a bunch of stuff here in this numerator, so you need to open up parentheses and type all of this in. The natural log of 3, close the parentheses on the natural log. You're still inside the big group though. Plus 2 natural log of 5. You open up parentheses for the natural log, close the parentheses for the natural log. You're done with the numerator now, right? So you have to close the numerator. Divided by, you only have this single term down here, right? Now, fortunately for us, it is just a natural log of 5, but to make sure we don't ever mess this up, you could go ahead and do parentheses and then say natural log of 5, close natural log, close the denominator. Because if this had been, say, maybe a 3 in front of this, if this had been 3 natural log of 5, you would have to put that whole thing in parentheses. For this problem, since it's just natural log of 5, we don't need it. I just want to make sure that we stay safe. And I get 2.683. How about you guys?
Yep.
All right. Now, this is not the only way that you could have solved this problem. So let me take you from this step right here, where we have x minus 2 times the natural log of 5 equals the natural log of 3. From this stage, we could have divided both sides by the natural log of 5.
That's what I started to do, and I thought it was going
I thought you were saying divide by natural log of 5 here. And that's where I was saying, let's not,
Oh,
just
okay.
wait. And so then we would have x minus 2 equals natural log of 3 over the natural log of 5. And then we can finish this by adding 2 to both sides. So the answer looks a little bit different, but it's still going to be the exact same value. Still going to be the same thing. So the guy's also going to lead you to that answer.
So 0.683 was ln 3 over ln 5, and the 2 is just ln.
Right, I mean, you can easily verify that if I do natural log of 3 divided by natural log of 5, yeah, there's that 0.683 plus the 2.